Hello guys, welcome back. So now we will be seeing problem number C, array elimination of Codeforces round 751 division 2. So in this question you are given array A1, A2, An consisting of non-negative integers. Let's define operation of elimination with integer parameter k, and k is from 1 to n. And what we are going to do is we have to do these three points. And what is that? Choose k distinct array indices like I1, I2, Ik, which means we have to choose k. For example, like if we choose k3, then we can choose three indices, any three indices from that array. Okay, which is from 1 to n. And after that, we have to calculate ai1, ai2, and aik, which means if we have to choose, if we are going to choose k3, then what we are going to do, we choose three indices from that array, and we are going to take their bitwise AND operation. And if you don't know bitwise AND operation, well, you can just read it from the Wikipedia. So in X, their bitwise AND is stored. Okay, and in third operation, what we can do is subtract X from each AI1, AI2, which means subtract X from each element which we have taken previously. So the question asking find all possible values of k such that it's possible to make all elements of array A equals 0 using a finite number of elimination operation with k. So it can be proven that exists at least one possible k for any array. Okay. And what is given in the note section that you first choose k and only after that performing elimination operation with value k if chosen initially. What this means that if you choose k equals to 2, then you have to make array 0 with only value of k equal to 2. And if you use k equal to 4, then you have to make the array 0 by using k equals to 4. Okay. So what we are going to do, we have to choose whatever the value of k, which is obviously less than or equal to n. We have to only choose k values from the array I1, I2, Ik. So input contain t and the array blah blah. Let's go to the logic part. So now let's think if we are given like value, so like this 1 0 1 1 1 1 0 0 1 1 1 0 0 0 1. We have given three values. This is some binary representation of uh, decimal number, which is I don't know. Just see this 1 0 1 1 1 double 0 1 1 1 0 0 0 1. So if in this case my k is 3, okay, my k is 3. So I want to make these three number 0. So for that, uh, what I want is if this is 1 and this is 1 and this is 1, and first I have to take their AND bitwise AND. So if I take their bitwise AND, then this bit of all three numbers will be 1, right? This will be 1. So when I just subtract this from this, then this bit will become 0. Okay, this bit will become 0. So now from this we can observe that if we want to make this number 0, then this bit in all the numbers should be set. Set means it should be 1. Okay. So what we have to do is like how many maximum bits are there? Like 31. Okay, 31 bits, 1 to 31. So what we are going to do is just store there in 0 in first position. This is first position, this is second, this is third, this is fourth, and so on up to 31. So what we are going to do is store in the first position how many bits are set. 1. In second position how many bits are set. And what we are going to do is make a loop from 1 to n, and we know that the k is from 1 to n. k is from and 1 to n. It cannot go like greater than n. So what we can do is we can iterate from 1 to n and just check if it is if this bit this for example, like if this first bit contains like three bits are set and rk is 3, then 3 modulus 3 equals 0. So what we can see from this is that if our total number of set bits is divisible by k, then we can make that number equals to 0. So what we can see here, for every k, like we have to make a loop from 1 to n, and we check from 0 to 31 for like if my k is 2, so I will check in all their bits if if all of them is divisible by 2. If it is divisible by 2, then I can make them 0 by using k equal to 2 or using two variables, two elements at one time. Okay, so let's clear this. What we can do is for loop 1 to n, and in this I am going to check 0 to 31 all the bits if it is divisible by if it is divisible by I. This is I and this is j. If it is divisible by I, which means all the elements in this divisible by I, then I can be our answer. Okay, so now let's go to the coding part. Here I have entered n, the array, and I have make this rest 33 to get all the to get store all the set bits in all the numbers, and I have inputted a. This is just a function to get the array, and I have make for j 0 to 32 to store in every place, like what I have just told, like 0 0 0 1 1 in like first position for every number, second position for every number, how many set bits are there. So this is what, if the bits are set, then just increment our counter for that particular bit position. And this is our answer vector, which contains all the k which is valid. So I am iterating from 1 to n, and I have created a bool variable OK, which is initially initialized by true. I am checking all the bit position. If this bit, if any of this is not divisible by what is I? This is our k from 1 to n. So if any of this is not divisible by, OK is false and break, come out of the loop. And if all the loops are complete, then OK will be true. So what that means is rest of j modulus I is always equals to 0, which means always divisible by I. So this can be our answer. So we will insert I into our answer vector and just sort them, because we have to give a sorted answer, and just output answer. We don't have to give sort answer, I think. Yeah. Oh no, you know, you have to print it in increasing order. Yeah. First sort the answer and then just print it. That's all. Thank you guys for watching. I will add this code link into my description. Thank you.